Right, today we're doing lesson 14-3, solve problems using ordered pairs. We're going to apply what we learned in the previous two lessons. The table below uses number patterns to describe changes in the width and the length of a rectangle. Let x be the width and y be the length. Then plot each of the four ordered pairs in the table on the coordinate grid. What do you think the length is if the width is 5? So our rule for the width is add 1, and for the length is subtract 1. So if we have 5, if we do it mathematically, if 4 plus 1 is 5, and then 8 minus 1 is 7. So let's show it on our graph. So we will plot the points, starting with 1, 11, 2, 10, 3, 9, 4, 8. And if we connect those points, and you should be using a ruler, which I am not using because it messes up my touch screen, but you should be using a ruler. I'll try to draw a straight line. And that didn't work. So if I continue on, my next point should be at 5, 7, which I figured out mathematically it should be at 5, 7, and now I can show it on my graph. So we have to make sure we connect the dots. And if I asked you what would be the width when the length is 10, if we continue our line, we will see when the length is 10, when the length is, when the width is 10, the length will be 2. So let's continue on. Both Ann and Bill earn the amount shown each week. Ann starts with no money. Bill starts with $5. How much will Bill have when Ann has $30? So on this graph, we're going to compare Bill and Anna's earnings, and we make a table. One starts with 0. It's important to know what you're starting with. And one is starting with 5. So when Anna has 0, Bill has 5. When Anna has they're each, let's see, sorry here. Whoops. They're each increasing by the same amount. I was just looking for that. I missed that. They have the same amount each week they're going to increase. So we always know that Bill's always going to have $5 more than Anna if they continue to earn the same amount every week. So when Bill has 35, Anna has 30. Whatever Bill has, you can subtract 5 to get Anna. And what is the relationship between Bill always has $5 more than Anna? Now when we get to doing some work on our own, in the example on page 790, find another point on the line. What does the point represent? So you can find any other point on the line you want, like 1823. That would say Ann's earnings are 18 and Bill is 23. In the example on page 790, write an equation to show the relationship between Ann and Bill's earnings. So whatever Bill has, which is the y-axis, is going to be whatever Ann has plus 5. You could say whatever Ann has equals whatever Bill has minus 5. And that is algebra, using those letters, the variables, to represent values that might change. Write the missing coordinates and tell what the point represents. So we're looking to see what does that little x, y, what is that x, y? And if I were to label x, y, it's over 5 and up 200. Now I want to look at the labels here. The jet car distance. So my x value is going to be time, and my y value is going to be distance. So we can say here are our points, and you can interpret it by saying at 5 seconds, the jet car has traveled, and we're looking at 200, and it's meters. That's how you interpret that graph. There you go.